Hey everyone, Mr. Skelton here. We are back at it with lesson 4 in unit 1, and today we're going to be talking about angles and the angle addition postulate. So really there's just one learning target today. Today we're going to use the angle addition postulate to find missing angle measures. Now the first thing we need to do as we jump into it is we need to talk about what an angle is, how you name it, and really that's about it in these first few examples. So let's take a look. An angle, so here's the symbol, and most of you know what an angle is. You've seen angles before, but that's the symbol. It kind of looks like the greater than or less than symbol. The only difference is it's flat here at the bottom. Okay, that's the angle symbol, and it's formed by two rays. You know what a ray is. We've talked about those in previous lessons with the same endpoint. That endpoint is called the vertex. Okay. So here's an example with a diagram right here, and it says name the rays that form the angle. That would be BT and BQ. And you can see that here. Again, notice that B is the first letter. That's because that's where it starts and stops. Right? What is the vertex? The vertex would be point B. And now when you name an angle, there's a couple different ways you can name angles, and I'll kind of demonstrate them through this question number 3. If there is a number, and oftentimes there is not, but if there is just a number in that kind of space in between the two angles, obviously the angle is created by the distance between the two rays. That's the actual angle measure. The 1 is just representing a number, obviously, and so we can call that angle 1. And so we could call that angle right there angle 1. The other way to name angles is by the vertex. If the vertex is all by itself, and I'll explain to you a situation where it's not by itself, but in this case, B is the vertex, we can call this angle angle B. Now the third and fourth way is naming an angle with 3 letters. And when you name it with 3 letters, the vertex always has to be in the middle. So for example, I could call this angle TBQ. I could also name this angle QBT. And if you notice, B is in the middle of both of those. Now, when you're naming angles, the most common that you're going to see is usually 3 and 4, where you're naming it with 3 letters. Okay? You can't name an angle with 4 letters or 5 letters or 6 letters. Usually it's just 3 letters. Okay? So I'm going to write that down. 3 letters to name an angle. And again, 1 and 2 can work, but this is a very basic example. We'll get into some more that are a little bit more detailed. Just make sure when you're using 3 letters, the vertex is in the middle. It says notice that when naming in angles, the vertex is in the middle letter, is in the middle letter named. I probably misspoke there, but you know what I'm talking about. B is in the middle there. Okay, so now here's a second example as we move down the screen here. This is a little bit more complicated of a diagram than the one just above it. So here's what we want to do. We want to name angle 1 in another way. Now angle 1 is basically just this angle right here as I trace my pen. It doesn't cut them all the way across. It starts at A, goes to B, and then finishes up at C. So A, B, C. So angle A, B, C. All right. Angle 2 says name in another way. I could name this angle CBD. So angle 2 is right here. I could go CBD. Now I could also call this, I'm going to say or, DBC. Angle DBC. I always tell students just trace with your finger. If I want to talk about angle 2, you just trace around the number 2. D, then B, then C. Or CBD. Now, what happens, I should probably do that at the top. I call this one ABC. I could call it CBA, angle CBA. Now the most common mistake on questions 1 and 2 is naming angle 1. A lot of students are going to say, oh, I'm just going to call it angle B. Well, what's the problem with that? On this problem, on the first example, we could call this angle B. In fact, that was one of our answers right here for number 2. But down here, what's the problem with calling angle 1 B? Well, B, point B, is really this whole part. So I don't know if you're talking about this angle 1 or this angle 2 when you just say B. So when your vertex is the vertex for more than one angle, like it is in this situation with angle 1 and angle 2 both having the vertex of B, you cannot use a single letter. You have to use the 3 letters to be specific. Again, I just say trace out the angle, A, B, C. That's talking about this right here, okay? And now question 3, I'm kind of getting ahead of myself. Name B another way. Now, angle B would be this entire, if I did say angle B, that's this entire thing. So if I wanted to name angle B another way, it would be A, B to D, because it would encompass both. So angle A, B, and D, okay? It says how many angles are in this figure. There's 1, there's 2, and then the entire thing, which is 3, all right? Now, some classification of angles. This might be review for you. I'll kind of highlight the important words. We got acute, we have a right, we have obtuse, and a straight. You're going to want to know these. So an acute angle has the following angle measures. An acute angle, I'm going to use a compound inequality here, is less than 90 degrees, but greater than 0. Okay, so basically it goes from 0 to 90 as an acute angle. A right angle is exactly 90 degrees. If something is equal to 90, if that angle x, I'm calling it angle x, I should probably use my degree signs. If angle x is equal to 90, it's right. Obtuse, the angle is going to be less than 180, okay, but greater than 90. That's obtuse, okay? And a straight angle is exactly 180 degrees. Now a straight angle, I'll give you a little hint here, is always just a straight line. A straight line always equals 180 degrees. That's why they call it a straight angle, because it's a straight line. All right? All right, let's go over the back here and let's talk about the angle addition postulate. So this is really a lot of the problems that you're going to be working with on your assignment has to deal with the angle addition postulate. Now, you've dealt with something very similar to this. The assignment 3 was segment addition postulate. Okay, and if you remember that, that was when we did whole plus, or excuse me, part plus the other part equals the whole thing. All right, and you'll see that down here in your notes. I kind of rewrite that. But here's how the angle addition works. It's really basic. It basically says is if B is in the interior of AOC, so where's AOC? Here's A, here's O, here's C, so that's this whole angle. If B is in the middle, okay, then what do we know? Well, if B is in the interior of AOC, then we know that angle AOB plus angle BOC has to equal the entire angle of angle AOC. I know it's a lot of letters, but just hear me out here. I'm going to put some numbers in here. Essentially, what I'm saying here is if I take angle 1 there plus angle 2, which is there, that equals the entire angle of angle AOC, which is this entire thing. Okay? So in other words, if you take 2 angles and add them together, you're going to get some bigger or larger angle. Okay? Here's the second scenario. If AOC is a straight angle, now key word there, straight angle, what does that mean? That means 180, right? So if AOC is a straight line or a straight angle, then what do we know? Well, take a look here. I know that angle AOB, so AO to B, plus angle BOC has to equal 180 degrees because it's equal to a straight line. Any straight line, this is a perfectly straight line here. This angle, I'll call it 1, that angle, I'll call it 2. In other words, angle 1 plus angle 2 has to equal 180 degrees. Whenever you have a straight line and you have an angle shooting off of it or a ray shooting off of it, those 2 angles together have to make 180. Okay? And we'll show you some examples here how we're going to apply that. So it says in both cases you can think part plus part equals whole, just like segment addition. Yeah, we just talked about that at the top there. All right? So it says use the figures below to answer the questions that follow. Here's the diagram. Now, it does have given information. You always want to see what the problem has in terms of given information. It says the measure. This little m right here, by the way, stands for measure. So you interpret this as the measure of angle DBC. Now always trace it. D, go to B, and finish at C. So it's the angle in between that V. So that's 24 degrees, so I'm going to mark it. And it says the measure of ABD is 83. ABD. So this entire angle from here to here is 83 degrees. Now what does the question say? It says find CBA. There's C, there's B, there's A. So I'm just going to call that X. So if you know the whole thing is 83, and part of that 83 is 24, how would you find this remaining piece? Well, just take your calculator out, or some of you may be able to do it in your head. 83 minus the 24, hit equals, and you get 59 degrees. Whenever we're talking degrees or angle measures, we always use the degree symbol. So there you go. Okay, let's look at the second example here. So this is more of an algebra type question here. Now, the first thing that jumps out to me on this example is that RT is a straight line. What do you know about a straight line? It's going to equal 180, right? So I'm kind of thinking that in the back of my head. Now, I'm going to mark down on my paper what's given to me. Again, here's your given information right here, okay? So it says RQS, R to Q, and then finish at S. I just go right down the line, R to Q to S, R to Q to S. So I'm talking about this angle right here is 5x minus 13. TQS, start at T, go to Q, finish at S, so the distance in between those is 3x plus 1. Now, if this angle here is 5x minus 13 and this angle right there is 3x plus 1, what do we know what happens when I add these two together? What do they have to equal? They have to equal 180 because they're on a straight line. So I would have 5x minus 13 plus 3x plus 1 equals 180. This angle here plus the second angle next to it has to equal 180 because they're on a straight line. This angle plus that angle has to make 180. And then you solve for x. So here's the equation. And now we solve. 5x and 3x make 8x. Negative 13 and 1 make a negative 12 equals 180. I add 12 to both sides, so I get 8x equals 192. And 192 divided by 8 should give me 24. Now, question number 2 says classify each angle, all right? So if I know that x is 24, I can plug that in for my x's. So I'm going to go 5 times 24, 5 times 24, hit equals, and then I'm going to subtract 13, so I get 107. So this angle is 107 degrees. Well, if that's 107, you could plug your x back in here for x, right? But if I know that that's 107 and I know the whole straight line is 180, I can just go 180 minus 107, and that gives me 73 degrees. Now I'm going to kind of redraw this so you can kind of see it without all the mess. R, Q, and T, and this was S, right? Now I have it backwards, but you get the point. If this is 107, this is 73. That should make sense because 107 and 73 have to make the straight line, which is 180. So it says classify RQS. Well, RQS was 107, so that's going to be obtuse. Right? Obtuse is between 90 and 180. SQT is 73, so that's going to be acute. All right. Why don't you hit pause and try the very last one, and then I'll see how you do. Go ahead and hit pause, try it, and then hit play when you want to check your answer. Okay, so this is a tougher one. You got some information here. Okay, and the first thing I want to do is recognize this little asterisk right here, because you see these little markings right here in between the angle. It says notice the markings on the angles, ... Those represent congruent angles. So when you see these kind of like little half circles, they're not straight lines, they kind of got a little roundedness to them. What that's telling you is, what you translate that is that angle AOB is congruent or the same as angle COD. Okay, those two angles are exactly the same measure. So if this is 58, that's 58. If that's 19, that's 19. They're the exact same thing. Okay. Now let's take a look at our given information. Our given information is that angle AOD is 107. Now where's AOD? Start at A, go to O, go to D. So this entire thing right here, that entire angle is 107. Okay? And it says angle BOC is 3 more than double AOB. 3 more than double AOB. So basically what you have is to translate this. This is a very tough question, all right? BOC is 3 more, so here's how you write this equation out. Angle BOC is always means equal. So BOC is 3 more than double AOB, 2 times the measure of AOB, okay, plus 3. All right? Now, that's what BOC is. So basically, if I call AOB X, I know this is X. So I'm going to put BOC, so BOC equals 2 times X plus 3. Okay? Now, if that's what BOC is, if that's what angle BOC is, then I'm going to take X plus 2X plus 3, which is BOC, plus this X and set it equal to 107. So essentially, if I want to find this entire angle, I need to take that angle plus this angle and set it equal to 107. So I get X plus 2X plus 3 plus X equaling 107. X plus 2X is 3X, another X is 4X, plus 3 equals 107. 4X equals 104, and 104 divided by 4 equals 26. So X equals 26. Now I want to find the actual angle measures. Find the measure of BOC. Well, what does BOC equal? I'm going to plug that 26 into 2 times 26 is 52 plus 3. So 52 plus 3 is going to be 55 degrees. Okay. It asks for angle BOD. So here's B, here's O, here's D. Now, BOD is going to be, if this is 56 and this is 26, right? It's 26 because we know what X is. It's 56 plus 26 gives me 82. And AOC is going to be AOC. So AOC is also going to be 82. Okay? Here's A, here's O, here's C. So it's 56, and again, this is 26 as well. Now, that's a very tough question to end on, but it's a good one nonetheless. That's a real hard question, but if you can make sense of all what I just did there, you'll be in good shape. Okay? If you have questions, be happy to go over them with you in class, and I look forward to seeing you.